Hello, we are Northeastern University's team for the 2018 NASA RASC-AL Mars Ice Challenge.
This is the Northeastern University's Planetary Articulating Water Extraction System, or PAWES for short.
This video will cover the progress we have made in the control, movement, and extraction aspects of our robot.
The current state of PAWES' control system is that all hardware drivers and interfaces have been built out as robot operating system nodes. This means that all actuators are individually controllable and all sensors can be read through the control station laptop. To control these components, we've also developed a graphical user interface through which the team can remotely control the system, monitor sensor information, and log competition critical data. This interface will be iterated and customized to form the final system control interface. Currently, we're developing autonomous algorithms that will end up controlling the system through mission objectives. This development is actually ahead of schedule and will be ready well ahead of time for testing prior to competition.
To prepare to mount the system on the NASA testing structure, we built a mounting frame that is the same 43 by 48 inch dimensions of the official structure. We also attached 4 bolts, each 1/2 inch in diameter, with the 3 inches exposed as the official mounting points. Additionally, if the position of the bolts changes slightly, the frame can be adjusted and can accommodate a variance of a few inches in all directions. The construction for the frame of the system is complete and there are no deviations from the proposal. The only hiccup that we have encountered is that there's a slight torquing that happens when the X carriage is driven. To resolve this, rather than driving it just on the top, we are intending to drive it at the top and the bottom with the belt and pulley. For progress on the extractor, the team 3D printed 2 parts to hold a spring for articulating. The 3D printed parts also have 3 routing holes that guide the strings. This assembly then will be used going forward to mount the heating element and used for testing of extraction before we build the final assembly.
The design of the drilling aspect of the extraction system has been advanced significantly from the original proposal. We took what was a variable speed corded drill that received AC power and stripped the trigger mechanism out of it. We did this because the drill needed to be controlled autonomously and the human element needed to be taken out of the drill's operation. We had some challenges identifying what type of motor the drill was operated with, but after some research and testing, we deduced that it was a universal motor. This will allow us to control the motor using DC power, which is our plan moving forward. Currently, the drill is ready to be mounted and wired, which will be accomplished using custom brackets on our 80/20 frame. Though the actual drill bit we intended to use was unspecified in our proposal, we have a 34-inch drill bit that will be more than adequate in drilling through overburden and ice.
The overall filtration design varies little from the original proposal. It's made up of 1 2-inch diameter PVC, 3 2 by 1/2 couplings, 3 1.5 by 1.5 couplings, and 3 half diameter nipples. It functions using a peristaltic pump and 3 solenoid valves. After water is collected and flocculation runs its course, soon as all the clean water drains, the debris valve opens to drain all the dirty excess. We always knew that some small amount of water was going to be sacrificed to the debris drain. To reduce the total volume of water that's dumped, we used a foam filler below the clean valve's height. We chose this foam sealant because it expands to fill any shape, it can be sanded, it holds to PVC, and is water resistant. Going forward, there is little to be done to finalize filtration. All components have been tested and flocculation has been quite successful. The next 2 steps are to mount the filter onto the mechanical frame and integrate filtration code into the overall system.